you are completely confused with M1V1 is equal to M2V2, N1V1 is equal to N2V2 in the volumetric analysis numericals, then stop right here. This video is for you. So here in this weekend special master class, we'll decode all your confusions, and here we'll solve some exemplar questions so that this concept will be more clear to you. I am Saranya, your chemistry ma'am. Let's get into the topic. So here I have written the formula M1V1 is equal to M2V2, N1V1 is equal to N2V2, and here these are the M1V1 plus M2V2. All these are the equations. Now I am going to explain these equations one by one. If M1 is the molarity of the solution with the volume V1, then here if you add some V2 ml, for example it is 100 ml and it is 0.1 molar solution, and here you have added some another 100 ml of water or solution to this. So here the new concentration will be, here number of moles remains constant, but the new volume changes and the concentration changes. The new molarity is M2 and the new molarity is M2. And here we have a relation M1 into V1 is equal to M2 into V2. Okay. Similarly, here you have a solution M1 with a concentration and with a volume V1, and here second solution with a concentration M2 with a volume V2, third solution M3 with a volume V3, so on. If you mix all these solutions, so the resultant molarity and the resultant volume will be given by the equation M1V1 plus M2V2 plus M3V3 is equal to or plus so on. If you add like that, so the resultant will be MNVN. That is this equation written here. Okay. Similarly, if N1 is the concentration of a solution with a volume V1 and you have added some V2 ml of the solution and the new normality is N2, then you have a relation N1V1 is equal to N2V2. Similarly, if you have a solution with a normality N1 and a volume V1, normality N2 and volume V2, and if you mix these two and the resultant new normality and new volume will be given by this formula. Okay. So here I think you got one clear idea about these relations. Okay. Now we will solve some exemplar questions so that this concept will be more clear to you. Okay. Write down the question. Calculate the volume required for 0.1 molar H2SO4 to neutralize 20 ml of 0.2 molar NaOH. Calculate the volume required for 0.1 molar H2SO4 to neutralize 20 ml of 0.2 molar NaOH. So first here, look at the problem. Here is asking you to find out the volume of H2SO4 and the concentration of, here one side you write H2SO4 to avoid confusion. On other side you write NaOH. Here he has given the molarity is given, it is 0.1 and volume you need to find out, and here he has given the molarity that is 0.2 molar, that is M2, and volume is, that is V2, it is 20 ml. Now whenever you are given a question like this, first you try to convert Molarity into normality. Here I'll tell you one masterpiece shortcut, that is the relationship between molarity and normality with an n factor. Normality is equal to n into molarity. Means here if you know normality, you can calculate molarity, or if you know molarity, you can calculate normality, and vice versa. Okay, so here whenever you are given a question like this, I told you, you convert first into the normality. So here first N1 is equal to, here you are given in molarity, no? So here N1 is equal to, what is the n factor for this one? Here normality is equal to n factor into molarity. What is the n factor for H2SO4? How many number of replaceable hydrogens are there? I told you, no? 2 replaceable hydrogens, n is equal to 2. So here the normality is equal to 2 into molarity, that is 0.1, 0.2. So N1 and V1 you need to find out. And similarly here also you convert this into, here for NaOH, how many replaceable OH minus ions are there? Only 1. So what is the n factor for NaOH? That is 1. So here N2 is equal to, here n factor into molarity, no? So what is the n factor? 1 into what is the molarity? That is 0.2. So what is N2? Here 0.2. And what is V2? It is 20 ml. Now you need to find out V1. Use the second relationship, N1V1 is equal to N2V2. So here we have written one side H2SO4 and another side NaOH, no? So here N1, what is your N1? It is 0.2. What is your V1? You need to find out your V1. What is N2? Again 0.2, and V2 it is 20 ml. V1 is equal to 0.2 into 20 divided by 0.2. So what is the new volume required? 20 ml. So what is the volume required? Volume of the H2SO4 required to neutralize 0.2 molar NaOH, it is 20 ml. Clear? So here you have looked at the question. You have solved one neutralization numerical without fail. Okay? Let's get into another problem. 100 ml 0.1 molar HCl, 100 ml 0.2 molar H2SO4, 100 ml 0.1 molar HNO3 are mixed. These are mixed. Calculate the concentration of resulting solution or whatever it may be. This is the first question. And the second question, first we will solve this first question. Now here I told you, whenever you are given the concentrations in the molarities, here you try to convert them into normalities. So here the normality of, so here how to find out, how to convert them into normalities? Normality is equal to n factor into molarity. So what is the n factor for HCl? N factor for HCl is 1. So here 1 into, what is the concentration? 0.1. So here it is 0.1 for HCl. And what is the normality of H2SO4? It is, what is the n factor for H2SO4? It is 2. So 2 into, what is the concentration? 0.2. So which is equal to 0.4. And what is the normality of HNO3? So normality of HNO3 is equal to, what is the n factor? 1. So 1 into, what is the concentration? 0.1, it is 0.1. So now here he asks you to find out the concentration of the resultant solution. So what will be the formula? N1V1 plus N2V2 plus N3V3 is equal to the new concentration N4 and the new volume V4. So here substitute the values. What is N1? It is for, this is 1, this is 2 and this is 3. So what is N1? It is 0.1. 0.1 into V1, here volume it is 100 ml. Plus what is N2? It is H2SO4. It is equal to 0.4 into volume 100 ml plus what is N3? N3 it is 0.1 and volume is again 100 ml. And here N4 you need to find out, and V4 is the new volume. Means here you are mixing up these two solution and the resultant volume will be V4, that is 300 ml. Okay. So here it will be 10 plus 40 plus 0.1 into 10. 10 is equal to N4 into 300. So N4 is equal to, the resultant concentration is, it is 60 divided by 300, 1 by 5. Means 1 by 5 means it is 0.2. Okay. So this is the concentration of the resultant solution. Okay. Now another bit here in this, calculate the concentration. You write down the second bit. Clear? All these exemplar questions are important to know the concept. Okay. So here B bit in this, here what is the concentration of the resultant solution? Write down the B bit. What is the concentration of resultant solution or resulting solution if the volume is made 1 liter by adding water. So what is your second bit here? Here what is the concentration of the resultant solution if the volume is made 1 liter, if the volume is made 1 liter by adding water. So what is the new concentration now? So here everything else is same. You need to convert this into normality. Here already we have done this in the first bit. So it is normality is equal to, here n factor it is 0.1 and it is 0.4 and here it is 0.1 again. Okay. Now here volume has changed to 1 liter, means here 1000 ml. So N1V1 plus N2V2 plus N3V3 is equal to N4V4. Here the volume they have made by made to 1 liter by adding some water. So here what is N1? It is 0.1 into 100 plus 0.4 into 100 plus 0.1 into volume 100 is equal to the new concentration. If we add some we add water and we made the solution 1 liter, means here 1000 ml. So what is your N4? Again it is 10 plus 40 plus 10. So here it is 60 divided by, here it is 1000, 6 by 100. So here it is 0.06. What is the resultant concentration? It is 0.06. I'll add another question. So here what will be the concentration of the resultant solution if we add some 700 ml of water? Solve this question on your own. What will be the general mistake here? Instead of everything is changed, everything is same, but generally common mistake done by most of the students is simply they will put 700 ml here, but that will go wrong because already you have 300 ml. To this you have added 700 ml of water. So the problem is same. So 300 plus 700, again it will be 700 ml. The answer is, the concentration is 0.06. Clear? Super clear? Okay. Well, next move into the another question. Fast. So I have clearly explained these relations and one master shortcut trick. How to calculate what is the relationship between normality and molarity with an n factor. Now I'll give you one homework question. So here calculate molarity and normality of molarity and or you solve this question here itself. Okay, calculate the normality and molarity of 12.6 grams of oxalic acid dissolved in 500 ml of solution. So calculate the molarity and normality he has asked. So here calculate molarity. Molarity, what is the formula? Weight by here number of moles of solute dissolved in 1 liter of a solution. So number of moles, weight by molecular weight into here in 1000 by volume in ml. If we convert volume in liters to volume in ml, this will be the formula. So what is the weight here it is 12.6 grams and divided by what is the molecular weight of oxalic acid? Here oxalic acid is COOH. Here he has given the formula twice 2H2O. So here with a molar mass 126 grams. So here it is 126 into 1000 by it is given in the question itself. Okay. So if you calculate also you will get 126. 100 by volume. What is the volume? Sorry, 1000 by volume is given, that is 500 ml. So here, so it is 2 and it is 0.1, 0.2. Molarity is 0.2. Now to calculate normality, here in your board exam also, here you can use this master formula, masterpiece shortcut. So if you calculate if you want to calculate the normality, you can first you need to find out the equivalent weight by putting molecular weight divided by 2. How to calculate the equivalent weight of oxalic acid? Here oxalic acid N factor is here COOH. It is oxalic acid. So how many hydrogens are replaceable? 2 replaceable hydrogens. N is equal to N factor for oxalic acid is 2. So here equivalent weight, molecular weight is 126 by 2, which is equal to 63. So here in your competitive exam it will take much time. So instead of that, here you know molarity and what is the N factor, it is 2 into what is molarity 0.2. So directly you can solve 0.4. Okay. Next question I will give you as a homework. Write down. I will give you a question on neutralization. Calculate. I will clear this one. Calculate the volume of 0.1 molar NaOH required for the neutralization of 0.2 molar 50 ml H3PO4. Now here I will give you a hint. What is the N factor for H3PO4? It is P double bond O OH. The structure will be how many replaceable hydrogens? N is equal to 3. So here you can solve this problem very easily. So immediately solve this problem and drop your answer in the comment section. Okay. I give reply to each and every answer. We'll see who comes first.